All right, let's dive into something really fascinating today. It's a new idea called scalar angular torsion theory, and it is a really bold attempt to build our entire universe, everything you see, from just a single, really elegant geometric picture.
So let's just start with this one big idea, because it's really at the heart of the whole theory. What if everything, every particle, every star, you, me, what if it's all just part of a giant four-dimensional tangle of threads?
So here's how we're going to unpack this. We're going to build it from the ground up. First, we'll look at this new picture of reality. Then, we'll see how it might actually piece together the standard model of particles. After that, we'll get into its really fresh take on gravity. See how it might just solve some quantum mysteries. And then, what could this all mean for the future of physics?
Okay, so let's get right into it. The whole thing, the entire universe, according to this theory, starts with just two fundamental building blocks.
So player number one is what's called a filament. Now think about any particle, its entire history, its whole journey through space-time, past, present, and future. That path it takes is a line. Well, in this theory, that complete 4D path is the real object. That's the filament.
And player number two, that's the time surface. The best way to picture this is as the slice of now. It's our present moment, and it's constantly moving forward through this whole 4D landscape of filaments, kind of like a scanner head moving down a page.
And here's where it all clicks together. This is the crucial point. What we think of as a particle isn't the whole thread. No, it's just that tiny, tiny point where the filament pokes through our present moment, through our time surface. The whole universe is this unbelievably complex tangle of filaments, but we only ever get to experience one slice of it at any given time.
Okay, so that's a cool picture, right? But how do you get from a bunch of tangled threads to the real world we know? The one with electrons and quarks and the whole standard model of physics.
Well, what's really clever here is that this theory doesn't try to throw out all of modern physics. Not at all. Instead, it reinterprets it. It says the standard model is just the geometry of this cosmic fabric. All the particles, all their weird behaviors, they're just different features of this underlying structure. And this is a fantastic analogy. Think about a guitar string. You pluck it, and depending on how it vibrates, you get different notes. Well, it's the same idea here. The way a filament is behaving, how it's vibrating, twisting, or angling, at that exact point it crosses our now, well, that's what determines the kind of particle we see.
And you can see just how deep this idea goes. A particle's mass, that could just be the angle its filament hits our time surface. A steeper angle means more energy, which, thanks to Einstein, means more mass. And other things like particle spin or flavor, well, those could just be different vibration patterns. Even the really complex forces that hold atomic nuclei together might just be filaments twisting and coiling around each other. It's all geometry.
All right, so we've got particles, but what about the big forces, like gravity? Well, this model has this beautifully intuitive explanation that just flows right out of its core ideas. See, as our now, our time surface, moves through this incredibly dense forest of filaments, they don't just sit there passively. They have tension. They resist. They actually exert this kind of back pull on the very surface of the present moment.
And this comparison really nails it. In Einstein's general relativity, we say mass tells space-time how to curve. But in this theory, it's the whole network of filaments that tells the 3D now how to curve. And that curved surface of now then guides how all the other filaments move through it. The end result looks just like gravity. It's a really subtle but super powerful shift in perspective. So we've covered particles and gravity, but what's really wild is that this model might even give us a physical reason for all the famous weirdness of the quantum world.
Now you gotta remember, these filaments exist across all of time. They stretch from the past through our present and on into the future. So this theory suggests that some interaction that happens in the future could actually send a tension, a force, traveling backwards along the filament and influence what's happening right now.
Okay, but hold on. This doesn't mean we can build a time machine and create all sorts of paradoxes. The physical properties of the filaments themselves, their tension, how flexible they are, they naturally put a limit on these backbleed effects. The influence from the future is already kind of baked into the filament's present state. And that might just be the physical mechanism behind things like quantum uncertainty. It could explain the weirdness without breaking reality.
So, what's the big picture? If this way of looking at the universe is right, what can it tell us that our current theories can't? Where do we go from here?
Well, one of the key predictions comes from a kind of blind spot in physics right now.
Our current theories don't really account for this tension that's being exerted on the present from both the past and the future. This theory says that very tension could be the source of tiny but observable anomalies, things that physicists are actually seeing in their data right now, but just can't quite explain yet.
But maybe the biggest, most profound takeaway is this. In this model, the vacuum of empty space isn't empty at all. It's also jam-packed with filaments. They're just aligned at a really shallow angle to our time surface, so now just glides right through them. That means matter and the vacuum aren't different things. They're one continuum. Matter is just a more angled, more energetic part of the very same underlying fabric.
And that leaves us with this final, really powerful question. For a century, physicists have been on this quest for a single, unified theory that can describe everything. Could this simple, almost intuitive idea, filaments and a moving surface of now, could this finally be the unified geometric picture that we've all been searching for?